introduce Chapter 8. Chapter 8, as I mentioned a moment ago, is really a continuation of Chapter 7 material. These really could be kind of squished together. In making my preparation, I noticed I moved some of my Chapter 8 stuff up into Chapter 7. So they're overlapping, if you will. Right? Or continuous is probably a better word. If you look at the objectives for Chapter 8, we're going to talk about what leads to the release of a neurotransmitter into a synapse. And that's really probably all we're going to have time to talk about today. But other objectives include the different receptors and the different neurotransmitters. We'll come back. And then we're also going to review the difference between an excitatory and an inhibitory synapse. And we already talked about temporal and spatial summation. And then we're going to look at specific neurotransmitters. Most specifically, we're going to look at acetylcholine and epinephrine, or even norepinephrine. So let's kind of put this into perspective. So far, we've been looking at a single cell. Within a nerve cell, receives a stimulus, may generate an action potential. Right? We looked at the basic structural components. But really, the point of the nerve is not to be inclusive, right? The point of the nerve is to talk to some other cell, some other nerve cell or some muscle or gland, or what we said is an effector, again, a voluntary control or involuntary type of response. So we need to go look at the end of the cell and look at the event that causes to release the neurotransmitter, which would then tie back to our Chapter 5 material of this intercellular communication. We're really trying to talk between cells. So up till now, we've been looking at within a single cell. We need to be more global and look at between cells. In my picture, it looks like this is supposed to be on the previous page, so I apologize. Oh, here's it. Mine's supposed to be on it. All right, so what we're going to do is look how multiple cells, nerve cells, communicate to one another. Before we can do that, we need to lay out some terminology, which I've introduced today, but we didn't formally use. The first is the term presynaptic. Presynaptic means what? Before the synapse. So if I use the word presynaptic, I'm talking about the cell that is releasing what? Neurotransmitter. So presynaptic cells are those cells which release neurotransmitter to some target. If the target is a nerve cell, we would call that cell the postsynaptic cell. So it's just variants of what we said earlier, source, target. The source is the presynaptic cell, the target is the postsynaptic cell. Just getting really specific now. We're saying, well, in the nervous system, the source would be the presynaptic cell, and the target would be the postsynaptic cell. Presynaptic cells may act on a postsynaptic cell in multiple areas. We know at least where. Presynaptic cells may act on a postsynaptic cell. What? The dendrites. The name, the specific name for where a presynaptic cell targets a postsynaptic cell, the dendrites, you could say all that. Or you could say an axodendritic synapse. Axodendritic synapse. It's a synapse between a presynaptic cell and a postsynaptic cell, it's dendrites. Is that the only axodendritic synapse we have shown in this image? No. Where else is there another one? Oh, yeah, it is. Sorry. It is the only axodendritic synapse. We may also see a synapse on the cell body, and that's called an axosomatic. Soma means body. They also have an axosomatic synapse, the axon terminal of the presynaptic cell, and the cell body of the postsynaptic cell. So an axosomatic synapse may be formed. There may also be a what? That's the last one. Axon to axon. It's axo-axonic synapse. I don't know how common where the terminal interaction is. I understand it would be more familiar at the hillock. Maybe I'm going to circle it here. Axo-axonic at the hillock. Axo-axonic would be at the hillock. I don't know how common it is at the terminal. In order for the presynaptic cell to affect the postsynaptic cell, it has to release its neurotransmitter. If it's going to release neurotransmitter, it has to first generate an action potential, which we covered in chapter 7. But the action potential is conducted all the way to the terminal, and if you recall, we said there are some voltage-gated, what down there? Calcium channels at the end of the presynaptic cell. We will fill this out on Tuesday, the next time we meet. But what I want to do is conclude with an image so that when you read it, you have a visual reference to come back to. I'm going to show the series of events that happen within a presynaptic cell to generate the release of its neurotransmitter. Here's a nice cool scanning image of the tip of a presynaptic cell cut open, and we can see the little colored neurotransmitters, or the vesicles with the neurotransmitters in them. Tiny little slice. It's like diamond. So in this animation, the action potentials are highlighted in yellow. This presynaptic cell is generating an action potential and conducting it towards the axon terminal. What color is the presynaptic cell? Green. The postsynaptic cell is purple. We can see the little vesicles at the end of the presynaptic cell. Action potentials can be conducted, and then what happens is it affects the permeability of those voltage-gated calcium channels. The voltage-gated calcium channels open, and calcium flows into the cell. You should recall that calcium acts as a second messenger and basically causes those vesicles to fuse to the membrane and exocytose their neurotransmitter into the synapse. So it's that influx of calcium that causes exocytosis in the presynaptic cell, the neurotransmitter. The neurotransmitter now just diffuses down its gradient and would bind with its receptors. And this is where we would see either an inhibitory effect at some synapse, causing potassium to, say, flow which way? Out of the cell, causing that postsynaptic cell to hyperpolarize. Conversely, some neurotransmitters would clearly cause the postsynaptic cell to depolarize the threshold, and we would call that an excitatory response. And what we'll conclude with next time is what happens to those neurotransmitters.